this section is going to talk a little bit about IP address management, aka IPAM products. The reason I'm bringing this up is because in any enterprise size business, and really once any business gets to a certain size, it becomes difficult to manage individual DNS and DHCP solutions at scale. So oftentimes what a business needs to do is they need to take both those solutions, package them into a single product that's easy to manage, to in order to have complete visibility into their entire DNS and DHCP configuration from a single pane of glass. Really, any enterprise product is designed to make managing something at scale that can be difficult, once you get to a certain size, make that a lot easier by packaging it together. There's also a couple of technologies we'll talk about, or specifically we're going to talk a little bit about Anycast, which is a protocol that DNS uses that essentially makes it available for multiple different servers or devices to have the same IP address, and clients can resolve that IP address based on how quickly they connect to an individual service. That's what makes IPAM useful at scale. So to talk about this a little bit, I've got a cheesy paint diagram up here, and this paint diagram just represents single, let's say small or medium-sized businesses. They have one physical location that's listed here, and in that physical location they've got a couple of domain controllers that has Active Directory integrated DNS. So I have DNS AD, and then let's just say they have a DHCP server. I haven't looked at DHCP load balancing in a long time, so I don't know what's available, but I remember back in the day it was an absolute nightmare because you couldn't actually load balance it. So I have two DHCP servers listed there, but for the sake of our example, it doesn't matter. They have DHCP service at this location. Now, this is working fine for them as a business, and let's say they ramp up a little bit and they add a second location. Now, that second location is going to have a separate physical network, separate IP address, and even if the two are connected with a VPN, they're still going to have separate resources, because if a client connects in location 2, they're not going to want to go all the way back over to location 1 to get a DHCP address and a DNS server, and they don't want all of their DNS requests going back over to location 1 in order to do name resolution. 1, it adds latency. 2, it adds extra steps and complexity of the network, and you don't really want all that traffic, especially not DHCP traffic, that's broadcast traffic, crossing over a VPN connection. So to remedy that, what they're going to do is they're going to have its own set of DNS servers, Active Directory integrated, which is they're probably going to have anyways, because you're going to want a domain controller at that second location to handle authentication requests. So you're going to have DNS there, and you just stand up another DHCP service to hand out addresses and make sure clients are pointing to the DNS. But what you get in this situation is you end up having networks that start to increase in complexity because you're adding multiple elements and different subnets and different addresses. And let's say each location has 2 subnets, because maybe you have a workstation subnet and a server subnet that you want separate. You want to separate for whatever reason. You're going to have your DNS servers ready to go and your DHCP server on some other IP addresses handing out addresses. You add that second location. Maybe they're not as organized. Maybe you did location 1 first and got 10.0. The second location got 10.1, 10.3, and then you had to add a new subnet to location 1 later at 10.4. So now your subnets look similar, but it's up to you to know different IP addresses are associated with different locations, and now you need some mechanism for tracking what these IP addresses and subnets are. Usually that comes down to a spreadsheet, or you don't have a spreadsheet and you're just relying on, when I need to look it up, I'm going to go look in the systems themselves to figure out what subnet is designated to which location. You also paired with this chart of like your different subnets and DNS servers and DHCP servers, usually that goes hand in hand with your Excel document that lists your server names and their IP addresses in each subnet for each location. So you have this usually Excel or a CSV sheet that lists, that's trying to map IP addresses to DNS names, because you need some mechanism for tracking that, or you want that for documentation. But now you have to manually update that. And anytime you stand up a new server, or if an IP address changes, or you're trying to track maybe printers, there's a million reasons why you want to track that. And DNS will work, but maybe it's not fully reliant. It's not fully reliable. You don't really trust it, so you want to maintain that separate list so it's easy and all in one location. This is a really common scenario in businesses, especially small to medium-sized businesses that have now grown to be growing towards a large or an enterprise business, and need to start reevaluating their tools. And what Microsoft has available in as like a product for Windows Server is you can use IP address management, which is a Windows feature, or a Windows role, I don't know which, and you install it on a Windows Server, and then it can detect and manage DNS servers, DNS zones, and DHCP servers in one view. So this is kind of Microsoft's solution for that spreadsheet conundrum of tracking different resources, because it allows you to look in one place in your IPAM server to get a list of all your different subnets, your DNS zones, and your DHCP scopes and the settings that are applied to each. It's essentially Microsoft's way of saying, okay, I'm going to package this all together, and I'm going to add automatic discovery so you can look in one place for all of your information. It is kind of a useful product because it does allow you to do some role-based access control, so you can have different designated levels of roles that allow your separation of duties. So like your help desk user can edit specific DNS records but not others that are protected, or they can manage records but not zones, or there's some other role-based control there. Where this falls short is you now have an extra server here that I'm just going to copy and paste. Oops, wrong layer. Hold on. You now have a separate server here for IPAM, and this has to go in a location, right? So it's either going to go in location 1 or location 2, and you now need to point this at each DHCP server and DNS server for management. So you're adding an extra server there that needs management, and all you're doing is using this one server to manage all these other individual servers, which means you still have the infrastructure and you still have all these different servers to manage that are doing a very similar service in providing DHCP for address handout and DNS for zone management and record management. If your DNS is Active Directory integrated and you have one DHCP server for each zone, I mean, you could stand up IPAM on a DHCP server and not have the extra one, but it's basically a bolt-on. It's an add-on product rather than being an actual solution for this. So this works as like a stopgap if you're encountering that IP spreadsheet management issue. That's very common. But where it falls short is that you're adding extra management and you're not really getting that much for the maintenance overhead of managing now another server role. So a lot of businesses skip this. This isn't a popular product, and the one place that I put it in use when I used to be a consultant, I was kind of disappointed in the lack of features that were available with it. So what a lot of businesses do instead is they skip this step altogether, and instead will implement enterprise level IPAM product, which looks more similar to this. So in an IPAM product, an enterprise IPAM product, and the two that I know of off the top of my head are BlueCat and Infoblox. they package DNS and DHCP together into a single web application and a console that you can manage, and it does those functions from one solution. So oftentimes you're at an enterprise, so you're not going to have just one because you want high availability, and so you're going to stand up two instances, an A and a B side, that at each physical location. That way, if you lose one instance at one location, the other one is still available to run. You can flip those back and forth for updates, and then if if you end up losing one entire physical location, now traffic can just route to IPAM server over your VPN tunnel temporarily to resolve DNS queries, so you're not completely out of business. That's assuming if both these servers are down, you haven't lost other network connectivity, but that's a separate issue completely. It makes your DNS and DHCP a highly available, reliable service. And then what makes this really cool is if you look down at your IP address schemes, whereas before you had your DNS servers, each DNS server has its own IP address. Your DHCP server had a separate IP address, assuming they're not running the same servers. And if you have multiple subnets, your DNS servers might be in different subnets, and you end up with 6 different IP addresses that you need to be aware of for managing. Switching back to this, oftentimes what these products will utilize is called Anycast, which is a protocol that allows multiple devices to have the exact same IP address at different physical locations. And then what happens from there is clients will use routing technology. Can I paste this here? This is like a diagram of Microsoft's Anycast route. The clients use routers. I can't remember what the exact protocol is. I think it's BGP, to determine the closest device that has that IP address to the client. So it'll say let's say all of these blue dots have a 10.0.0.1 IP address, and that's the Anycast address that the boxes have. In this case, it'd be your DNS servers. The clients say, I'm connected to the router, I need 10.0.0.1. That router says, oh, this is the closest one, I'm going to send you directly to that, just based on route and time. Now, if the client was over here instead, let me just, because I got paint, let's say the client's over here and connects to that. Now the route could go here or it could go here, and it doesn't really matter. It's going to connect to one of those devices because they're closer than going over here. And it's really just the cost of the route itself that determines which solution you connect to. But what's cool about that is, in order to use DNS server, you're not specifying the name. You don't have a mechanism for load balancing that. You have to give it an IP address because it's up for the DNS server to determine the match between the name and the IP address. So you need the ability to just give it an IP address and have that navigate automatically to the closest network location. So this enables that feature, that concept. So your IP or your IPAM solutions or your IPAM devices are going to have 2 IP addresses, and it doesn't matter physically what location you're in. You're connecting to the same DNS and DHCP servers everywhere, so that's always going to work. So it uses that Anycast protocol to connect clients and always return the results. So let's say if you stand up now, let's say you're standing up location 3, you don't need to bother changing DNS or DHCP. You know for a fact, once that's stood up using Anycast, you're going to have the exact same DNS servers for any clients everywhere. You just use that 10.100.0.5 and 10.100.0.10, and you're in business. Your DNS, DHCP are automatically going to connect, even if it's a separate physical location, just using that loopback address. And if you lose those servers in location 2, your location 2 clients are now just going to use Anycast and route either here or here. They don't need to change any settings. They still have DNS and DHCP, assuming there's still VPN connectivity between those sites. So you get a lot more reliability and high availability from an IPAM product at an enterprise level using this Anycast protocol than you would trying to manage multiple DNS or DHCP servers. So once you get to a certain scale, this is the more popular solution. And oftentimes these come with a single login. So any of your help desk technicians, any of your systems admins, engineers, they just log into their IPAM solution and they can get all their DNS and all of their DHCP settings in one place from anywhere in the network. So it's a much better solution when managing at scale. So that's the DNS IPAM overview section of this. The next thing we're probably going to be looking at here is some unique DNS situations and scenarios that you might come across. So that will be coming up next. Thanks.